Hello friends. In the last video I had talked about what is a label transition system and how it can be used to check the behavior of a system. Now in this video I'll be talking about a bisimulation relation which is used to compare two systems according to their behavior. That is, we compare the behavior of two systems. Now what exactly is this bisimulation relation? What does it tell from a label transition system? Now first we'll know what exactly is what is this bisimulation relation. So the bisimulation relation is something this consider that I have two label transition systems, say some A1 and A2 for and there is a state some S in A1 and S dash, and here I have some state T and T dash. For me to tell that S is related to T, that is, there is a bisimulation relation between S and T, I should follow these rules. That is, if there is an action or a transition with an action A from S to S dash, then a similar transition from T to T dash should be there here also. That is, if S to S dash, if S to S double dash, there is some other B, then T to T dash also I should have T to some other state. It may be like T triple dash. I should have a B. If S2 there's some state like S1, if I have a C, then there should be a state from with the transition and action C to some other state like T1. So if there is a transition with an action in one LTS, then there should be an equivalent transition for that action in another LTS. This is the first condition of bisimulation relation. The second condition is just the vice versa. Second condition is just vice versa. If there is a transition from in the second label transition diagram, if it is like T A to A dash, I should have in the first transition diagram also A to S dash. So the same thing follows here. What we studied in the first, what we had learned from the first rule, same thing. If there is some B to some other T1, then there should be a B to some S1. So we should check both the outgoing, we should check the outgoing transitions in each state in both the transition system, label transition system. If all the states in label transition system A1 are having a bisimulation relation, with all the states in transition system A2, then we can tell that there is the behaviors are equivalent. Let me take an example for that. I've already drawn an example. Yeah. Consider this label transition system. I will take this as A1 and this as A2. Tell me whether these are equal, whether these label transition systems give the same behavior. Oh sorry, I have left two things. This is a B action, here also there's a B action. Now let us consider with the given rule that if there is a transition from S to S dash with the A, then I should find a same transition in from T to T dash. Okay, let me see that. For S1 and T1 to be to have a bisimulation relation, I should check the outgoing transitions, that is the actions what it performs to go to the other state. So let me take it. So S1 has a transition to S2. T1 has a transition to T2. Okay, so this is done. Then let me change the color. S1 has a transition to S3. T1 has a transition to T2. So I can use the same transition because this depending on this action. If the action is same, there's no problem to use the same transition here also. For two transitions in A1, I can use a single equivalent transition in A2. There's no problem with that. But there should be a transition for that action from T1 to T2. Okay. Now this part is done. Now let me come to the second level here, this level. Again, let me consider S2 makes a transition to S4, a B transition to S4. So S2 makes a B transition to S4. T2 makes a B transition to T3. Okay, done. Can I tell S2 and T2 are equivalent? No, because I have left one transition in T2 to T4 in A2. So let me consider that. T2 makes a B transition to T4. S2 makes a B transition to S4. Now I can tell that there is a bisimulation relation between S2 and T2. For two systems to exhibit same behavior, all the states should satisfy the bisimulation relation. So I should check the bisimulation relation for S3 also. So let me consider S3. S3 makes a B transition to S5. T2 makes a